Hi there, this is Jacob Nash Review, and we're going to be looking at describing data for AP Statistics. This is lesson 2 of the lessons that there are. So hopefully I can make as many lessons as I can, but sometimes it takes a long time to make these videos. So sorry if I don't make that many, because that's happened before. But anyways, SOX. This is not something I made up, but it's a good acronym for describing data. So these are 4 different things that if you had like maybe a FRQ or something, you would want to talk about these things so that you could describe the data. That is shape, outliers, center, and spread. So let's talk about those 4 things. Shape. Well, depending on what kind of display there is, which we're going to talk more about in the next lesson, it might look a little bit different, but if it was like this is sort of like more like a histogram look. It could be symmetric. So you see this? That's just like kind of like a pyramid if it was a histogram. So it's like, oh, wow, the tallest thing is in the middle. That sometimes is what you would expect. But it can be skewed. So pay close attention to this because this is easy to mix up. Look at this, skewed right. Doesn't it look like all the things are on the left? That's why it's easy to mix up. So you just kind of have to think about if this was a hill and you were like on a skateboard and you were going down that, where would you go? You would go to the right. So that's how you know it's skewed right. Then over here, this is skewed left. If you started right here, you would go to the left. So it's skewed left. So that shape. Outliers. We're going to talk more about that in a minute, about how to calculate that. But this is just unusual points that don't fit the pattern. So if you had a linear graph, maybe if you remember in algebra, that one dot that's not, or I should say a scatter plot, that one dot that's not in the line, that's the outlier. But sometimes we just think something's an outlier. We have a way to calculate it, but we're not going to talk about that yet. Center. The center of the data can be either the median or the mean. Well, that seems annoying. Either. We hate those things in AP, don't we? Well, here's how you know. If it's symmetrical, like looking like a pyramid or just something like, oh, so nice, we can use mean. But if it's asymmetrical, so if it's skewed or some kind of thing that's like, that's just dumb or like extremes in there, then we're going to use the median. Why, though? Well, we're going to talk about it in a minute, that the mean is it is affected greatly by extreme scores. So remember, the mean is the average. Think about a grade that you might have. Let's say you have a 95 in a class. Maybe that means you've gotten a bunch of A's on test grades. So that makes sense. That maybe you have symmetrical data, so we can use the mean to determine something. But think about if you got a 0 in the grade book because you were absent. What the heck is that going to do? That's going to make your grade go way down. So, and your grade is your average. So, whereas if your teacher used a median, then you might still have an A. So don't we wish they used median sometimes? So that's why if there's extremes, we use the median. Which it is often that we would use the median anyways, because there are extremes a lot. All right, the spread. The spread of the data is just showing the variability. So how different is the data? Is the data just all consistent, like, or is it like kind of crazy? So we can use range, standard deviation, and interquartile range. So let's see, you might have only heard of the first one. So let's talk about what they are. Well, a range is the highest minus the lowest. That just tells you how wide of a range your scores are. That's why it's called that. So let's, like, going back to the thing, let's say if we were looking at the range of your test scores, if you got that 0 and let's say your highest grade was 100, the range is 100 because you've gone from as lowest as 0 to as high as 100, and 100 minus 0 is 100. Now, standard deviation, there is a formula for this, but luckily we don't have to use that dumb thing. We can type this into the calculator. That's something that's pretty good. So I'm not going to talk about that completely yet. but that really what it is showing how far away the scores are from how much they vary from the mean. So if you let's say someone gets a bunch of 50s on their tests, well, then the standard deviation is going to be small because their average might be a 50. And if they've only gotten like 50s, 49s, and 51s, then that's pretty close to the mean. So it's a small standard deviation. But let's say someone got a bunch of 100s and then they got some zeros too, and then that made their grade a 50. Well, then there's going to be a big standard deviation because you're not getting close to 50. You're getting zeros and 100s, but it just happens to be 50 when you do the average. So that's why standard deviation is useful, because things can have the same averages, but they're completely different. The interquartile range, this is quartile 3 minus 1. If you don't know what that means, that's okay. We'll talk about it in a minute. Oh, modes. Do you remember what mode is? Mode is the number that appears the most. Well, there's different kinds of modes that data can be. Maybe what you're most used to is unimodal. That means that there's only one most common thing. So if you see, I can't really read, is that 2? So 2 would be the mode for this, and that's the only mode that there is. Now bimodal, well, that's what it sounds like. There's 2. So there's 2 and 4, they're both modes. Multimodal, that's like just a whole bunch. I mean, it could be 3, it could be 6, could be 36, whatever. And then uniform, it's like, what the heck? Seems like they're all the same pretty much. So there's no distinct modes. So there you go. That looks all the same. Calculating mean. Remember, we do this to describe the center, but only if it's symmetrical. The mean is the sum of all the numbers that there are divided by the number of numbers that there are. And you can choose to remember this one that I just said, or you can look at that one. That's kind of dumb to me. But you need to know that in statistics, the symbol for mean is a letter X with a line on it. So it's like a X that has a hat, like, oh. But I don't know, there's no point in really using that one because it's a lot simpler, in my opinion, to just, we add all these numbers. So let's say we're trying to find the mean of this. So we're going to do 16 plus 37 plus 39 plus 17 plus 22. That's on the numerator. On the denominator, it's the number of numbers. 1, 2, 3, 4, 5. There are 5 numbers. This formula is saying the exact same thing, but in more difficult terms. So we can type that into the calculator. Remember, you want to do parentheses around this so that it doesn't try to divide 22 by 5 before it adds to things. So 16 plus 37 plus 39 plus 17 plus 22. 131. That's the sum of those. All right, divide that by 5. The mean is 26.5. Like clear, right? I don't know why I said that out loud, but I have to clear. All right, median. Median is the number in the middle. And remember, this is the more common thing that we can use to describe the center because it's not affected by extremes as much. So put the numbers in order and then cross them out until you get to the middle. You got to put them in order. So let's do the median for both of these. So let's do 7, 23, 27, 32. We can kind of cross them out as we go so we know which ones we've already said. 35, 89. And then we'll put this one in order. 18, 21, 27, 43, 97. Okay, so let's just start out with this bottom one. We cross them out until we get to the middle. The median is 27. All right, let's do it. Huh? What the heck? Oh, what do? You crossed out all of them because there's an even amount of numbers. Well, now we have to take the average of those two numbers. Remember the average, we add them together, divide by how many there are, there's 2. So let's do 27 plus 32, that is 59 divided by 2. the median is 29.5. The median can be a decimal. So that's something you got to know. All right. Oh, and I already kind of talked about this, but let's just see why. The mean is affected by extreme scores more. Let's see why. All right, let's find the mean of these numbers. So the mean of 17, 18, and 20, add them together, divide by 3. That is, the mean is 18.3. Well, let's see what the mean is now that there's another number, 99. All right, and that's obviously an extreme score. And score doesn't always mean like that it's grades. That's just what we call it sometimes. All right, we have to divide by 4, not by 3 this time. Oh, that's crazy. Now it's 38.5. That's a lot higher. All right, what about median? All right, median, 18. Median, all right, since we cross everything out because there's an even amount of numbers. We do this. You might know that that's just 19. So which one changed more? 18.3 to 38.5, 18 to 19. The mean obviously changed a lot more. So you got to know that that's the reason why we can't use the mean to describe the center if there's extreme scores, which 99 is extreme score. That's why. All right. Quartiles. All right, quartiles. These are just 25% of data. Well, if you think about it, 100% is the full thing. You divide that by 4. Quartile, that quart usually sounds like 4, doesn't it? But we only talk about 1, 2, and 3 because if there was 4, that's kind of pointless because that would just mean it's the highest thing that there is, pretty much. Like, so we only talk about 1, 2, and 3. Quartile 1, that is where 25% of data is below and 75% is above. So if you got your ACT score and it said you're in the 25% quartile, that just means that basically you scored higher than 25% of people, but 75% of people scored higher than you. The second quartile is when there's 50% below and 50% above. So if you scored in the second quartile, that means pretty much you might think average. That's not really accurate to say. It's really the median if you think about it, because that means it's in the middle. The middle is not always the average. But you could say that you scored higher than 50% and 50% scored higher than you. Third quartile, 75% below, 25% above. So you scored higher than 75% of people. 25% of people scored higher than you. All right, 5-number summary. If you notice the slide is a different color, I just did that to make you pay attention. I also make AP psychology videos, and I sometimes have a crazy audio when you're supposed to remember something, but I forgot to add that. But anyways, the 5-number summary is something very useful to help describe data sometimes, and it includes these things: low, quartile 1, 2, and 3. Quartile 2 is just the median, and then the highest value in there. So luckily, you don't have to do this mathematically. You can do this in a calculator. So pay close attention. If you have a graphing calculator, which hopefully you do if you're taking this class, because it's very useful to use, you might want to pull that thing out and do this along with me. So here's what you do. First, you push the button stat. See, it's right here. Stat. Here, let me do this. Stat. Next, once you push stat, you'll see this screen. Push 1 or enter, because it's already on 1, to go to edit. What are we editing? Well, we're editing these lists. You don't want anything in these. If you were just playing around with the calculator one day and you put something in all of them, just X that out by pushing del. But we're going to add the data, whatever data you had. So let's say this was the data: 11, 22, 33, 44, 55. Wasn't very creative with that data, but I just felt like doing it. So you type that into L1. All right. After you do that, then you just push stat. And that's going to take you back to the screen that we were already on. But we're not going to push edit again because we just did. So we're going to push the right button to go over to calculate. See, now we're on calculate. Then push 1 or enter, because once again, it's already on 1, for 1 var stats, 1 variable statistics. So then when you go on that, then push calculate. After you go on calculate, there will be a bunch of different things. Push the down button, down, 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 until you see these things. This is the minimum. This is quartile 1. This is quartile 2, or the median. Quartile 3, maximum. Oh, what do you know? It did it for you. That's how you do the 5-number summary. All right, standard deviation. Remember, I said I was going to talk about this more. Remember, that was how much do things vary around the score. This is our spread in SOX. Here's the real formula. Now note, there's 2 different formulas for standard deviation. There's one that has this thing that kind of looks like a, I don't even know what you would say, like a G on like a 2009 keyboard. No one uses a G like that anymore, that had its bottom off. But it also kind of just looks like, to me, like a bomb almost. But never use the bomb one. That's for a population. But we are doing, in statistics, we do 99 out of 100 times we use sample, which is S. So use the S one all the time. So we don't do that one, but luckily you don't have to do this formula. It's pretty complicated, as you can see, and it takes a really long time because you kind of have to like write a table and then like square a whole bunch of numbers and do a bunch of crazy things. You don't want to do that. Just do this again, and once you get to this part, calculate, you'll see that above these numbers there will be this SX, and that is the standard deviation of the sample that you want to use. So that's how you find standard deviation. All right, empirical rule. This is very important. Credit to Wall Street Mojo. I just got that picture from there. What does this mean? Well, there's something that's called the bell curve. You might have heard. That's just like the average look of a graph sometimes. And one standard deviation is 68% of people, or whatever it might be, is in one standard deviation. 95% is in 2 standard deviations. 99.7 is in 3. You need to remember those percents: 68, 95, 99.7. Well, let's talk about it. Oh, I didn't mean to have these things already in here, but whatever. So pretend that the standard deviation is 2. All right, we found out that for this, whatever this happens to be, the standard deviation is 2, and the mean is 29. So here's the 29. So 68% of the data is going to be in between 27 and 31. Why? Well, the standard deviation is 2. So we do 29 minus 2, 27, 29 plus 2. That's 31. So 68% of the data is within 27 and 31. 95%, so that's 1 standard deviation. 2 standard deviations, that would be 4. So 29 minus 4, 29 plus 4. 3 standard deviations. 2 times 3 is 6. 29 minus 6, 29 plus 6. So hopefully that makes sense. All right, finding outliers. Remember, that's the O in SOX, and I told you we were going to figure out how to do that. So remember, oh wait, I might have not said it. Oh, I did, but you didn't know what the quartiles were yet. But the interquartile range, IQR, is quartile 3 minus quartile, I can't say that, quartile 1. So here are the formulas that we use. If this doesn't really make sense to you, then just kind of forget that part. Just know this part. So we're going to see right here. Let's see, we have this data here. Is 48 an outlier? If quartile 1 is 23 and quartile 3 is 37. So the red dot is where 48 is. Well, it might kind of look like it's an outlier. But we can't just go by what we think. We have to actually use math to know. So using this lower limit formula, we just plug it in. So quartile 1 is 23. The IQR is 3 minus 1. Quartile 3 minus quartile 1. So that's 37 minus 23. And when you type that into the calculator, you get 2. What does that mean? Then that means that all the data has to be greater than 2. Greater than 2. And if it's not, then that's an outlier. So 1 would be an outlier for this data. 0 would be an outlier. And then what about quartile 3? Or sorry, what about the upper limit? Well, it seems like it's the same formula, but it's not, because we have to use quartile 3 and it's a plus. So you have to remember plus, don't do minus for both of them. That's 58, so that means everything has to be less than 58 for it to be not an outlier. Well, 48 is in between 2 and 58, so it is not an outlier. If the question said is 59 an outlier, we would say yes by this, because it has to be in between 2 and 58. All right, graphing with frequency. So sometimes there can be something like frequency. So see this data, what if we were trying to find the standard deviation? Well, it's not the same exactly, because we have to type both of these things. Remember, for stat, we do L1 and L2. So we type something into L2. So let me go back to show you what I mean. So see, L1, we would type the other things into L2. Another thing that you have to do is see one var stats. We're not going to do that this time. We're going to do 2 variable stacks. So we would push 2 instead. So that's what we do if there's that. All right, now let's do some practice. This isn't practice for everything, because I don't feel like doing one of the ones where you find the 5-number summary, but just know that, or the quartile range, just know that you have to do that. These are just kind of like questions that you would just know. A student scored in the 70th percentile on, oh, and earlier, I'm sorry if I said quartile, I meant percentile when I was saying that. 70th percentile on her history exam. What does this student score mean in relation to other test takers? Her score on the exam was 70%. No, that doesn't mean that. That's probably what someone would guess if they didn't know anything about statistics. So hopefully that's not you. Her score was in the top 70% of the test takers. That kind of sounds right. Let's keep going. Her score was worse than 70% of the test takers. No, it's not that. It was better than the 70% of the test takers. That is what it is. Now, see, of course, in AP, we know that there's always another one that tries to throw you off. In that case, it might have been B. It was in the top 70%. Well, top 70%, that actually means that B and C are saying the same thing. If her score is in the top 70%, then that's actually not good, because then that means it's only higher than 30% of people, which is saying that it was worse than 70%. So the answer is D. All right, the salaries of 235 nurses were recorded and analyzed. The analyst later found that the highest salary was incorrectly recorded as 10 times the actual amount. After the error was corrected, the report showed that the corrected value was higher than any other salary. What sample statistic must have changed after the correction was made? Well, if it's higher than any other salary, then mode would not change. And we're saying must have changed. There are some that possibly could have changed. The median possibly could have changed, but it depends on the layout of the data. If there was a bunch of 18s in a row or something, then it might have not changed. But we know for sure that the mean must have. The minimum obviously didn't. Hopefully we know that. But it's the mean, because if it was recorded, like we said, extremes affect the mean more. 10 times the actual amount, that means it would be something crazy. It would make the mean way higher, but when they take that out or when they correct it, then it's back to normal. So, and it's a lot lower. So must have changed, that's the key word. The median could have changed, but it didn't. We don't know that for sure. We know for sure that the mean must have changed. Okay, thanks for watching. I hope this video helped. There you go.